Welcome to this GCSE Maths video. This is Bob Steele here. This video is going to cover solving 1, 2 and 3 step linear equations. It's also going to look at changing the subject of an equation. The equation solving part of this covers GCSE grades E for the 1 step ones and grade D for the 2 and 3 step ones, stretches up to about the bottom of grade C. So for anyone who's serious about coming out of their summer exams with a grade C, if you are weak on this area of algebra, this is something that you really need to get into, study, practice, because you can pretty much guarantee that this is going to come up. So let's get straight into this. I'm hoping you're not going to have any difficulty with these first four. There's only one step required to solve these. So looking at this first one, something plus 5 is 13. What I've seen some candidates do is add 5, because they see a plus 5 here, and say that the answer is 18 and then move on to the next question without stopping to check or stopping to think. The answer can't be 18 because 18 plus 5 is not 13. So what we need to do throughout all of these is use inverse operations. Inverse meaning opposite. So if something plus 5 is 13, to get back to what that something must have been, I'm going to need to subtract 5. It's not a very good 5, is it? I'm going to need to subtract 5. And if I do subtract 5, that's going to leave me with x equal to 8. Yep, so let me just write that in there. X equals 8. Check your answer. 8 plus 5 is 13. Moving on to the second one, I see that C minus 9 is 16, so the inverse operation of that minus 9 is to add 9. And adding 9 to the left hand side of the equation, the minus 9 and the plus 9 cancel each other out, so I'm left with C plus 0, which is just C. And on the right hand side of the equation, the 16 plus 9 is going to give me 25. So my solution to that second one is that x equals 25. You want to test your answer. 25 minus 9 is indeed 16. Moving on, 3 and the A next to each other. Remember, in algebraic notation that means 3 times A. We just don't show the times sign. So as long as you're on top of your times tables, you should be alright with this. 3 times what is 24? The answer is 8. So as I said, invisible time sign here. So if A has been timesed by 3, the inverse operation of timesing by 3 is to divide by 3. And 24 divided by 3 gives me that A equals 8. I've just noticed here in the second question I used the variable C, and then in my solution I used x. So let me just correct that. There we go. Final one on this page. Y divided by 7 equals 4. The inverse operation of dividing by 7 is to times by 7. So if I multiply by 7, 7 times 4 is 28. So my solution is that y equals 28. If I want to test my answer, 28 divided by 7 is 4. Not going to spend any more time on the one-step ones. Let's move straight into these two-step ones. So, looking at the first one, to solve these, we need to get the letter, in this case X, C, A, Y, on its own. So, look at that first one and think, well, what happened to X? Well, the first thing that happened to X was it got multiplied by 3, and then 4 got added. So if I want to work backwards to get X on its own, I am firstly going to have to subtract 4. So that's the inverse operation of the thing that was done most recently. And then when I get to this 3x, x has been multiplied by 3, so my inverse operation is going to be to divide by 3. Common mistake with something like this is to try and deal with this 3 first. Can't do that. You've got to deal with any plus and minus here, and then whatever's attached to your unknown. So if I subtract 4 from 25, that's going to leave me with 21, and 21 divided by 3 is 7. So my solution here is that x equals 7. Testing your answer, 7 times 3 is 21, plus 4 is 25. Second one's quite similar to the first one. Think about what happened to C. It got times by 2 and then 7 got subtracted. So my inverse operations are firstly to add back the 7 that got subtracted, and to separate the C and the 2, the C was times by 2, so I'm going to have to divide by 2. So 15 plus 7 is 22, 22 divided by 2 is 11. So my solution is that C equals 11. Now 3 and 4 are similar in that they both have a division, but there's something I don't want you to get caught out by, because in 3 the division just applies to the A, but in 4 the division applies to all of the left hand side of the equation, and that affects where you go from here. So again, think about what happened to A. It got divided by 2 and then 4 got added. My inverse operations are to subtract 4 and then multiply by 2. So 12 minus 4 is 8, and 8 times 2 is 16. So my answer is that A equals 16. Checking it, 16 divided by 2 is 8, 8 plus 4 is 12, so that works. Now, this last one, because all of the left hand side is divided by 3, it's the division by 3 that I'm going to have to deal with first. Common mistake with this is to try and tackle this plus 7 first, because it looks like it might be similar to this, but no, I have to deal with the division by 3 by first timesing by 3. And if I times by 3, I'm going to get that 2y plus 7 equals 27. Now that I've done that, it looks very similar to the first equation on the page. So from there I am going to subtract 7 and then divide by 2. 27 take away 7 is 20, and 20 divided by 2 is 10. So my solution here is that y equals 10. Let's put it to the test. 2 times 10 is 20. 20 plus 7 is 27. 27 divided by 3 is 9. So there we have some 2 and finally a 3-step equation being solved. If you can solve equations, then changing the subject of an equation should be okay. In this equation at the moment, c is the subject because it's on its own on one side of the equation. There's no plus, minus, times or anything attached to it. It's just on its own. We need to come up with a new equation that's just got t on its own. So as we did on the previous slide, look at what's happened to t. It's been multiplied by 3 and then p has been added. So my first step, I am going to subtract p, and I'm going to do that from both sides of the equation to keep the equation in balance. So my first line of working out is going to look like that. Now remember, 3t means 3 times t, so to separate the 3 and the t means that I am going to have to divide by 3. I'll just write in there that I subtracted p. So as I just said, my next step is going to have to be to divide by 3, and the division by 3 applies to all of c minus p. So I need to write all of that gets divided by 3, and now I have t on its own. Doesn't matter that it's on the right hand side of the equation. I could swap those left and right hand sides over and the answer would still mean the same thing. So take a look at that. On my VLE page in weeks 7, 8 and 9, there's a whole load of stuff on algebra. In the week 8 folder there's a help sheet that covers this plus all of the solving equations. Like I said, if you feel a bit weak on algebra, this is the stuff that you need to go back and look at, because it will most definitely turn up in your GCSE exams. Thank you for watching and listening. Bye.